Hi, so we are going to use these 4 ways of representing inverses with an example. So our first example is that our function f of x equals x plus 2. Okay, so we are going to talk about all the different things that I showed you originally as to how you can represent x plus 2 in these different methods. So the first thing is that ordered pairs. So you can get ordered pairs from like your calculator if you need to. This time we can just do it in our heads because it really doesn't take very long. So our function f of x, we have our x value and our y values, which remember is the same thing as our f of x values. So then whatever we get there, the inverse function is going to switch them. So let's put in like a negative number, -2. Let's put in 0 because that's always easy, and a positive number 5. Okay, so if these are just some of the points of the function. So if I put in -2 into right here, -2 plus 2 is 0. If I put a 0 in over there, I get a positive 2. And if I put a 5 in there, I get a 7. Now these are just some points because these points are going to help us with our graph. So these are just a few of our points, but the inverse of these points, remember, is just when we switch them. So instead of -2, 0, it's 0, -2. Instead of 0, 2, it's 2, 0. And instead of 5, 7, it is 7, 5. All right, so these two are the inverses, and it's just when we take the points and switch, which really helps us be a little bit more specific with our graphs. So if we go through, if we go through and graph our first function, -2, 0, let's see if I have enough room. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Let's go up just a little bit higher. 6, 7. 1, 2, 3, 4, 5. All right, so if I graph these points of the original function, -2, 0, that's my x-intercept. 0, 2, that's my y-intercept. And then 5, 7 will be up here. 1, 2, 3, 4, 5, 5. And then up 7 will be up here. So it just makes a straight line. Okay, if you were to put it into your calculator, you get that line. All right, and remember, the inverse function flips or is the mirror image of whatever we get. So since this line is up here, then when we do the inverse, it's actually going to flip it to the other side. And the nice thing is that because we were a little bit more precise with our graphing, with our points, then we can actually get a more precise graph. So 1, 2, 3, 4, 5, I think I have to go up to 7, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Now we're just doing this by hand, but the line should eventually look like it's down below. And I am going to do it in red so that we can see the difference. So now I'm just going to use these points from the inverse function. 0, -2, 0, -2, 2, 0, 2, 0, and then 7, positive 5, 7, 5 up here in the corner. All right, so we connect those. Okay, that's our inverse line, and if you compare it, here's y equals x. It goes right through the origin, and our function was on the left upper part of the line y equals x, and so the inverse has flipped it to the other side. So if you were to combine these, they would look like a mirror image. The blue line would be on the left side, and the red line would be on the right side, on the lower right side. All right, so then the equations are going to look similar to what we did on the last example, where the original function, the original equation, f of x equals the f function is y equals x plus 2. And the reason why I rewrote that is because, remember, we want to switch x and y. So even though it does say f of x, I'm going to put in a y there because when I go through and do the inverse, I want to go ahead. It's easier to switch those two variables than to switch an f of x in there. So I switch x and y. And then remember, I solve for y, so I subtract my 2 over. That way it goes away on this side and it shows up over here. X minus 2 is y, and then it's a little bit easier to see this way. Y is x minus 2. So just like that was written, f of x equals x plus 2, we could say the inverse is x minus 2. So it means the same thing down here, because remember, we took out the f of x, we put in y, so we can take out the y and we can write it with f of x instead if we'd rather. So here's the original, and then the inverse is when you switch the variables and then resolve it so that y is leading again. And then we talked again about composition, how now when we take these two things, they should give us an x in the end. Remember, we're always looking for equals x. So the first one I'll do is f of its inverse of x. So I'm going to take f of x, which is x plus 2. Its inverse is x minus 2. We just found that right there. So I'm going to take out the x and put in x minus 2. Negative 2 and positive 2 cancel out, and there's the x that I want. Now we want to do it the other way to make sure it works in both directions. So the inverse of f of x. So the inverse function is x minus 2. The original function that we're substituting in is an x plus 2 right here. So I'm going to take out the x, put in the function x plus 2, positive 2 and negative 2, they cancel as well, and they should, because in the end, we should get x whenever we work it out either way. So this helps us prove or show that these two are inverses of one another, and then these lines and everything. So ordered pairs show us, graphs show us, the equations show us, and we can use them, and then this proves those equations.